Hello and welcome to this video on place value. Now we're going to be considering possibly the deepest question in mathematics. How do we represent the count of how many things we have? Now it might be that we use a dot to represent each thing we have, but the thing is if we have a lot of things that we want to represent a large number of things, then we can see that we're going to have lots of dots. So that's not a particularly practical way as soon as we start getting to hundreds and millions and such. Another way you might have seen is using a tally where each strike represents a whole, which again is useful for small numbers, but to represent large numbers you're obviously going to have to use a lot of lines. And in the ancient time, and I mean really ancient, like kind of caveman times, this is a way that we could have represented value. Now what we can do is we can count how many tens we have. So each row is 10 dots, so you can see that we have 2 tens. And then how many dots do we have here in the last row? You can see we have 4 what we call units. So a unit is just one thing. And that would give us the number 24 because we have 2 tens and 4 units. So we can see that that is the tens digit, the 2 is the tens digit, and the 4 we call the units digit. And with this example we can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have one lot of 10. And then we can see we've got 2 units left over. And therefore that gives us a number of 12. We've got 1 10 and 2 units. So let's consider the place value of all of our different digits here. We saw that the last digit is known as the units digit. And we saw the digit to the left of it is the tens digit. And each time we go left, the digit is worth 10 times more. So what's 10 times bigger than 10? Well, it's 100. So the next digit would be the hundreds digit. And if we kept on adding digits, let's say we had a 5 to the left of it, well, the value of the digit is 10 times more. So 10 times more than hundreds would be 1,000. So we say that's the thousands digit. And we can keep going. So we had a 7 there. Now there's not any special word for this. It's the 10,000s digit. And if we add 2 more, that would be the 100,000s digit. Again, no special name. But we do have a special name for this one. This is the millions digit. And then you could keep going. You would have the 10 millions after that, then the 100 millions, then the billions, then the 10 billions, then the 100 billions, and then the trillions. So we get into very, very big numbers. And note, by the way, that when we have big numbers like this, starting from the right, we count each 3 digits and we tend to put a comma like that. So another 3 digits, 1, 2, 3, and then a comma, starting from the rightmost digit, not from the leftmost digit. So the commas allow us to see the place value of each digit a bit more clearly, because I know that if I've got 3 digits and then another 3 digits, then the digit just before that would be the millions digit, and you just kind of get used to that over time. We can actually, in fact, go in the other direction. So if we put a decimal point here, we're now going to break up a unit into kind of parts of a unit. So if I had a digit here, that is known as the tenths digit. So remember, each time we go in this direction, each digit is worth 10 times more. So if we go right, it's worth 10 times less. So the tenth digit is a tenth as big as the units digit, 10 times smaller. And then we can keep on going further. So this would be the hundredths digit. Notice the th on the end. And then we'd have the thousandths digit. And if you keep on going on. And just to give you a better idea of what I mean by 1/10, let's just say that this square represented 1 unit. Then 1/10 would be just a tenth of that unit. So I could break this up into 10 pieces. And 1/10 of it would look like that. Now, the questions you often get in exams is to state the value of a particular digit, what each digit is worth. We've got 230, we'd say that's 230. Now, what is this digit worth? Well, that's the units digit, so that's the tens digit, and what we do is we say it's worth 3 tens. That's the value of the digit. So you need to include the actual digit itself. The 3 has to be in your answer, and then you say the place value, so it's worth 3 tens. Or you're allowed to say that it's worth 30. What about the second one? So we got 4, 5, 3, 4, 2, and notice my use of a comma there. We want to work the value of this digit. Well, it's worth 5, but 5 what? Well, this is a units digit, this is a tens digit, the hundreds digit, so this is the thousands digit, so it's worth 5 thousands. Or we could just write it as, well, it's worth 5,000. Third one, we got 3754. What is that 4 worth? Well, that's a units digit, so it's 4 units. Next one, question 4, 5740,000. I'll put the commas in, starting from the right, 1, 2, 3, comma, 1, 2, 3, comma, and we want to know the value of this digit. Well, that's a units digit, tens digit, hundreds digit, thousands digit, 10,000s digit, 100,000s digit. So it's worth 700,000. Or again, you could write 700,000. That's what the 7 is worth. And 5, we got 3.567. Remember, the digit just before the decimal point is the units digit, so that one must be the tenths digit. So that is worth 5/10. What about the next one, 6? We got 453.709. And that 9, well, that's the tenths digit, that's the hundredths digit, and then that's the thousandths digit. So that's worth 9 thousandths. And then finally, we've got 58.345. And we want to know the value of that 4. Well, that's a tenth digit, and that is the hundredths digit, so it's worth 4 hundredths.